we look at global numbers, it's actually 63 billion animals raised for meat, egg, and dairy products. Deforestation for animal agriculture emits up to 2.4 billion metric tons of carbon dioxide each year. The FAO has found that farm animal production is a major driver of deforestation, both to convert wooded areas to pasture for grazing and also to convert it to cropland, to grow feed crops like corn and soybeans. As a result of deforestation, large amounts of carbon are emitted into the atmosphere because forests act as carbon sinks. Brazil's forests in particular are increasingly being destroyed, both for cattle grazing and also to grow feed crops. And the loss of Amazon forests is particularly troubling from a climate change perspective because Amazon trees may sequester an amount of carbon that's equivalent to more than a decade of human-induced global emissions. Between 1990 and 2005, just during that 15-year period, 80,000 square miles of Amazon forest were destroyed. At the same time, the area's cattle population increased by about 40 million animals. Desertification emits up to 100 million tons of carbon dioxide every year. Desertification is the degradation of land in arid, semi-arid, and dry subhumid areas. And it tends to reduce their productivity and the amount of vegetative cover. So ruminant animals and raising ruminant animals tends to contribute to this because of overgrazing. And when we say ruminant animals, we're talking about animals like cattle, goats, and sheep. On-farm fossil fuel use emits up to 90 million tons of carbon dioxide annually. And the amount of fossil fuels that are going to be used at a particular farm is going to vary depending on the type of production system we're talking about. Fossil fuel use in factory farms or industrial systems where animals are continuously confined indoors tends to differ from the energy that's going to be required in a more extensive system where animals are raised outdoors. Globally, industrial systems account for 67% of poultry meat production, 50% of egg production, and 42% of pork production. Factory farms, the one pictured is an egg farm, require substantial energy inputs for things like lighting, heating, cooling, ventilation, and automated machinery for feeding and watering the animals. Now, when the FAO calculated this figure, it also included some of the resources needed to feed animals in intensive systems, including fossil fuels used to produce seed, herbicides, and pesticides. And again, all of that is going towards growing feed crops. Approximately 40% of global grain production is used for animal feed. Now, when we feed these grain crops to animals first, rather than feeding them to people directly, a significant amount of energy is lost converting grain matter into animal protein matter. To grow these feed crops, primarily corn and soybeans, vast amounts of nitrogen fertilizer are used, which is manufactured in factories using fossil fuel energy. 41 million tons of carbon dioxide are emitted annually as a result of fossil fuel to manufacture fertilizer, and an additional 28 million tons as a result of releases from cultivated soils. Again, all of this is going to grow feed to feed farm animals. Processing animal products emits several tens of million tons of CO2 a year. Now, some animal products require more fossil fuel energy during processing than others. For example, the FAO notes that it takes more energy to produce 1 dozen eggs than it does to produce 1 kilogram of beef. Transport, both to transport feed to the animals and to transport animal products to consumer markets, also emits carbon dioxide. Now, it's important to note here that when the FAO calculated transport costs, it did not include the transport of live animals, either within a country's borders or internationally. Turning now to methane emissions. Again, methane from animal agriculture is about 37% of annual human-induced emissions. And farm animals are actually the most significant source of human-induced methane emissions globally. Methane emissions from animal agriculture tend to come from two places. One is enteric fermentation, which you may also hear referred to as cow burps, and one is animal manure. Enteric fermentation emits 86 million tons of methane a year. Now, enteric fermentation is part of a ruminant animal's natural digestive process. It's what enables them to consume plant matter that monogastric animals like us can't consume. Sorry. Individual animals produce very little methane, but again, it's the numbers. It's the 1 billion ruminant animals worldwide that collectively become such a significant source. Turning again back to farm animal manure, farm animal manure is responsible for 18 million tons of methane emissions a year. In the United States, between 1990 and 2005, methane emissions from pig manure and from dairy cow manure increased by 37% for pig manure and 50% for manure from dairy operations. And the EPA attributed this increase to the trend towards confining these animals in larger operations that use these manure lagoon systems, which, as I said, are customary for large pig and dairy cow operations. According to the Pew Center on Global Climate Change, growth in farm animal populations, especially in large confinement operations, has greatly increased emissions of methane, both from the animals themselves and from their manure. Finally, turning to nitrous oxide. 70% of human-induced nitrous oxide emissions come from crop and farm animal production combined, with animal agriculture accounting for 65% of those emissions. In the United States, again, between 1990 and 2005, nitrous oxide emissions rose by 10%. The EPA has attributed that rise in part to changes in the US poultry industry, including an overall increase in the numbers of birds raised for meat and eggs each year. So all of that brings us to the question, what's being done about this problem, and what else could we potentially be doing? Well, thus far, many of the strategies that are being undertaken are along the lines of technical strategies. And these are some examples listed here. One is to reformulate the diet of ruminant animals to control enteric fermentation. Another strategy being used by some of the larger producers is to